context of front-end development, POHO stands for Plain Old JavaScript Object. While the term originated in Java as Plain Old Java Object, front-end developers use it to describe a standard JavaScript object, the kind you create with curly brackets, rather than an instance of former class. POHO versus class instances. When the text says state is POHOs, not classic instances, it's highlighting a shift toward data-only structures. Feature syntax POHO, plain old JS object, cons user equal open semi-curly bracket name colon quote alice closing semi-curly bracket semicolon class instant cons user equal new user quote alex semicolon. Feature methods usually contains only data. Class instance often contains methods logic. Feature serialization easy to turn into JSON strings. Class instance hard to serialize. Methods are lost. Feature immutability easy to clone. Open semi-curly bracket user comma age colon 30 closing semi-curly bracket. Class instance harder to clone without losing classness. Why modern front-end React Redux prepare POHOs? Serializability. So another thing is that this data only preserve the integrity of the system, just like our previous discussion. State in modern apps often needs to be snapshotted, saved to local storage, or sent over a network. POHOs are just text-like data. Classes contains internal state and functions that break when you try to save them. So since the class has a methods or has a state, when you try to save them and to your local storage or send it to other network, those state are often lost. With POHO, those remain the same. Predictability. In frameworks like React, the UI is a function of your state. If your state is a POHO, you know exactly what is in it. If your state is a class, it might have internal variables or private methods that change without the framework noticing, leading to bugs where the screen doesn't update. So this is the accidental bug, and it is also the reason why Redux save those state or methods in the global state. So if their state is a class, it might have internal or other dependencies like the previous right of the global state that it is dependent to. That's where we get a lot of bugs. Immutability. Redux and modern state tools rely on comparing old state to new state. It is much cheaper and safer to create a shallow copy of a POHO than it is to reinstantiate complex classes. So the reason it's cheaper is because if you reinstantiate complex classes, you might introduce unsynchronized or race condition data. So even though you have a new snapshot or kind of have like a new version in GitHub, those are cheaper because at least you get a consistency across all your users. Key takeaway, using POHOs keep your application state flat and pure. It ensures that your state is just information while your components or utility functions handle the logic, kind of like separating the code stream and data storage. Plain old Java object explanation. So versioning data is often an afterthought in these libraries as they are intended for quick and easy encoding of data. They often neglect the inconvenient problems of forward and backward compatibility. So because of that, the data specific of programming language is not really reliable. So you need to use the common programming language that has been battle tested, not programming data format that has been battle tested that keep its consistency across networks such as JSON, XML, and binary values, because it also keep with forward and backward compatibility as your application grows. Efficiency, CPU time taken to encode or decode, and the size of the encoded structure is also often an afterthought. For example, Java's built-in serialization is notorious for its bad performance and bloated encoding. So this library or this language specific data format also took a lot of time to encode or decode from the CPU pipeline or in the CPU execution units that cause a notorious performance. For these reasons, it's a generally bad idea to use your language built-in encoding for anything other than very transient purposes or for very special cases. JSON, XML, and binary variants, moving to standardized encodings that can be written and read by many programming languages. JSON and XML are the obvious contenders. So these two are the data format that can be used or like interchange with different languages. That's why with PostgreSQL or any app that you would think that communicate in web browser today use this. So either JSON or XML because they don't dare to use their own data format because of the obvious drawbacks with performance and compatibility. They are widely known, widely supported, and almost as widely disliked. XML is often criticized for being too verbose and unnecessarily complicated. JSON's popularity is mainly due to its built-in support in web browsers, by virtue of being a subset of JavaScript and simplicity relative to XML. So that's the reason why this data format thrive because it's supported by web browser because web browser has a built-in JSON parser. So programming language took their time to add this or to integrate this data format to be able to support it, to be able to easily use their language to this main platform, which is web browser. And also it's a subset of JavaScript, which also the main platform, the uh, programming language being used in this main platform. Besides the superficial and also it's relatively simple than XML. CSV is another popular language independent format, albeit less powerful. JSON, XML, and CSV are textual formats and are somewhat human readable. Although the syntax is a popular topic of debate, so JSON, XML, and CSV are textual formats, meaning they are more readable than binary format, which we will discuss later. And they are also kind of more readable than the built-in encoding format of the programming language. And their syntax is still a popular topic of debate. So a lot of people are criticizing, but since they support a wide range of cases now, it won't likely to change as fast. Besides the superficial syntax issues, they also have some subtle problems. There's a lot of ambiguity around the encoding of numbers. In XML and CSV, you cannot distinguish between a number and a string that happens to consist of digits except by referring to an external schema. So here, let's say you have a string that also have like you have a letters that also have a number. You cannot distinguish that in XML and CSV, so that's the disadvantage of that, except that you refer to an external schema. Remember, the schema is what organize the tables in the database, or the yeah, organize the furniture. It's the room where the what says what furniture in this room. JSON distinguishes strings and numbers, but it doesn't distinguish integers and floating point numbers, and it doesn't specify a precision. So this is the disadvantage of JSON, is that it doesn't have uh, differentiation with floating number, which as we know has been long supported by the CPU architecture. This is a problem when dealing with large numbers. For example, integers greater than 253 cannot be exactly represented in an IEEE 754 double precision floating number. So such numbers become inaccurate when parsed in language that uses floating point numbers such as JavaScript. So again, this is a problem with dealing with large numbers. For example, integers greater than 253 cannot be exactly represented in an IEEE 754 double precision floating point number. So such numbers become inaccurate when parsed in a language that use floating point number such as JavaScript. So if you have JSON and then you have a language that would parse that floating point that you requested, you'll get an inaccurate result. An example of numbers larger than 253 occurs on Twitter, which uses a 64-bit number to identify each tweet. The JSON returned by Twitter's API include tweets IDs twice, once as JSON number and once as a decimal string, to work around the fact that the numbers are not correctly parsed by JavaScript application. So they have the separated, or they include the tweet ID twice and the one as a decimal string separated to work on this problem. JSON and XML have a good support for Unicode character string, i.e. human readable text, but they don't support binary string sequence of bytes without a character encoding. So this is the reason why they have binary encoding is different from JSON, because JSON support a more human readable text, but they don't support an encoding of that character into the actual disk, or like putting that squeezing that into bytes on the disk that we can actually store in the database. Binary strings are a useful feature, so people get around this limitation by encoding the binary data as text using base64. So they get around by using, or by still using the binary feature, or putting a more like binary text or binary representation in JSON by using base64, which represent a binary as a text. The schema is then used to indicate that the value should be interpreted as a base64 encoded. So to be able to read that in JSON, you would need a schema that would can read or interpret the base64 encoded. This works out, but it's somewhat hacky and increases the data size by 33%. Compared to using binary code, it actually decreases JSON size by 23%, something like that, but it basically decreases. There's optional schema support for both XML and JSON. These schema languages are quite powerful and thus quite complicated to learn and implement. Use of XML schema is fairly widespread, but many JSON-based tools don't bother using schemas. So, though there's a schema that could support a quite complicated and advanced feature in JSON, they don't bother using those schema because just JSON it is are compatible for almost use cases. While in XML, a use of schema is widespread because again, this is a more complicated language than JSON. Since this is a more complicated data format. So JSON is not a language, it's just a subset of JavaScript. Since the correct interpretation of data, such as numbers and binary strings, depend on the information in the schema, applications that don't use XML or JSON schemas need to potentially hardcode the appropriate encoding or decoding logic instead. So this data would not stand as it is if like you're supporting particular schema such as binary, if you don't also support that in your logic or application logic and decoding code. So it has more work in that scenario. CSV does not have any schema, so it's up to the application to define the meaning of each row and column. So unlike JSON and the XML, which JSON doesn't use schema anyway, as much anyway, CSV does not have any schema at all. So it's up to the application to define the meaning of row and column. So you get more work in your application code to define what that bytes or data format mean in your particular database. If an application change adds a new row or column, you have to handle that change manually instead of automatically. So basically, you have to change your code a lot. You cannot like create the code and then let the user interact with it and then change data as we go. You cannot do that in CSV. CSV is also a quite vague format. What happens if a value contains a comma or a new line character? Although its escaping rules have been formally specified, escaping or terminator, line terminator, not all parsers implemented them correctly. So, though there's an escaping rules that allow parser to help parse it easily, just like the JSON and XML, not all parsers actually consistently implement them correctly. Despite these flaws, JSON, XML, and CSV are good enough for many reasons. It's likely that they will remain popular, especially as data interchange formats. For sending data from one organization to another, in this situation, as long as people agree on what format is, it often doesn't matter how pretty or efficient the format is. So again, despite these flaws or pros and cons of JSON, XML, and CSV, it's good enough for a lot of purposes and use cases. It's likely that they will remain popular, especially as data interchange formats for sending data from one organization to another, or from sending bytes from in-memory to one organization to another in memory and to their to their directly to their database. In this situation, as long as people agree on what the format is, it often doesn't matter how pretty or efficient the format is. The difficulty of getting the different organizations to agree on anything outweigh most other concerns.